Good morning, everybody. I'm Leif Nelson, and thanks for coming to the Data Colada seminar series. Today, our speaker is going to be Keith Chen. And in addition, we have three panelists, Dorothy Kronik, Abhishek Nagaraj, and Ricardo Perez-Trulia. In addition, Joe Simmons and Yuri Simonson will be here as well. During the talk, you can submit questions or comments through the Q&A function, and all of the panelists will have an opportunity to read them and potentially voice them to Keith. But even if we don't get to all of them, they're all recorded and they'll be given to Keith afterwards anyway. With that in mind, Keith, the floor is yours. It's all yours. You are muted, though.
It wouldn't be a pandemic talk if I didn't do that at least once. It's wonderful to see you guys. Thank you so much for the invitation, and thank you so much for to the panelists for agreeing to kind of give feedback on this. So let's just dive right in. I wanted to kind of give this talk and talk about kind of broadly speaking two things. One is the topic, which is an investigation of partisan cognition. It's obviously in some sense like one of the kind of, I would say, most important topics in kind of behavioral science as we see it, right? And you could think that in some sense like partisan decision making, increasing partisan cognition to the degree that it interferes with collective decision making, kind of is the linchpin for unlocking a lot of challenges that face us collectively. The other thing I'd like to kind of point out in this talk, and that I'm excited about talking about, is that many of you have probably, especially audience members of this series, probably really interested in new techniques, new data techniques, thinking about evidence and all kinds of new ways of doing social science. I'm going to be talking entirely about projects where we use smartphone location data, which is a relatively new, I'm very excited about, form of data that in some sense represents a tremendous democratization of kind of big data for kind of computational social science. We all know that we all carry around smartphones in our pockets, and that Google and Apple know almost everything about us. Twitter knows a lot more about us. Dating websites know a lot about us. I'm going to talk about, in some sense, like a recent democratization of that data, where basically kind of anyone who's a working social scientist can get not full access to like the depth of the data that those companies have on us, but a non-trivial chunk of it. So I'm very excited about all of that, and looking forward to diving in. All right, I'll spend one slide on this: partisan cognition and partisan antipathy. I think we all kind of feel this in our bones, so I don't feel like we need to spend a lot of time kind of doing it, but just put some numbers on it. Basically, people the secular trend here in this graph, like since at least the 1980s, a very popular measure utilized by political scientists, you could think of these as thermometer scales, basically show that like we like ourselves just as much as we ever have, but we dislike people who we think associate with a different partisan identity than us increasingly. So that the red and the blue lines up there at the top are exactly what you think. They, relatively flat lines show Democrats still like Democrats, Republicans still like Republicans. That kind of feeling has not changed really since the 1980s. But that yellow and the green line that are declining secularly basically say, if you identify as a Democrat, being willing to say very nasty things about Republicans, that's on the up and up. And same thing with if you identify as Republican, being willing to say very nasty things about Democrats. Other ways of thinking about this, there's a lot of survey measures that ask, suppose your child brought home a potential significant other. What characteristics would make you really upset about that person? The like who's coming to dinner kind of question. And that your child might potentially be interested in forming a long-term relationship with someone from the opposite party now outranks race, now outranks basically any kind of religious affiliation, as something that people are potentially quite upset about. Okay, so we'll call this partisan antipathy and distrust, and that's just growing. So the interesting question that we're going to try and answer here is that this is survey evidence that seems to be growing in surveys. There's a lot of political science literature that talks about the degree to which kind of cross-partisan bill writing and kind of things like this are increasingly difficult in American politics. But what we want to answer here is, is there evidence that that partisan antipathy is increasingly affecting people in like high stakes decision making, right? So think kind of our current situation with respect to COVID-19. How much is that reducing your willingness to get vaccinated? How much is that decreasing your willingness to participate in local institutions like, in your local PTA? And here we're going to look at like really high stakes decision making, like how much is that decreasing your willingness to do things like get a vaccine or evacuate from an oncoming hurricane to the degree that those kinds of issues become polarized. That's what we're going to be talking about. I'm going to hide my video for 1 second. Another way of seeing this, another way of thinking about this, and this is also going to be one of the ways that we're going to use data to identify a lot of these effects, is that what I'm showing you here is presidential elections running from 1992 to 2016. The spatial units you see on these maps, I know Abhishek loves spatial units, so we're gonna be talking a lot about kind of spatial units. The spatial units you see on this map are U.S. counties. Okay, so you should think about these as like spatial units that aren't being gerrymandered, that aren't really kind of changing from year to year. And if a county is shaded at all, what it means is that in that presidential election, it's swung by more than 20 percentage points. So like it went at least 60-40. And then the deepest color counties that you see here basically went by 50 percentage points, like 75-25 for one candidate in a presidential election. So one way that you want to think about this is that what this is telling you is that politically, at least on the micro level, America is becoming less and less politically competitive. Another way of thinking about this on a personal level is fewer and fewer Americans are living anywhere near someone who voted differently than they did. Okay, that's kind of just a fact of modern American life. Let me preview some of the results that I'm going to show you today about like effects that we can measure using smartphone location data, which I'll talk about in a second, especially with respect to kind of this partisan cognition and partisan antipathy. I'm not going to talk a lot about these results, but I'll mention them because they're a little bit of a warm up for the results that we're going to talk most about. In an early study, my co-authors and I looked at partisan antipathy and Thanksgiving durations. So we basically, this was our kind of warm up of like learning to use smartphone location data. And effectively this grew out of the fact that I had an extremely kind of, many of us in this co-author circle had extremely uncomfortable Thanksgiving dinners in 2016. This is a holiday where Americans are typically supposed to get together with their close loved ones, but it immediately followed one of the most contentious kind of presidential elections in American history. What we show in a study is that Thanksgiving dinners, where the two family units that get together likely voted for different candidates, so likely a Clinton voter and likely a Trump voter, those Thanksgiving dinners were 47 minutes shorter. Okay, and we do that comparison in a couple different ways than other Thanksgiving dinners that involve traveling the same distance from the same locations to the same locations. And in fact, for a smaller sample, than that same Thanksgiving dinner in 2015. So these same two families got together in 2015. How long was their Thanksgiving dinner? Now they get back together in 2016. Families that get together that voted similarly see no reduction in Thanksgiving dinner times. Families that voted differently see a reduction of approximately 47 minutes. And then we can try and get at causes by saying, does that effect seem to be stronger if there was a lot of political advertising in your area? So, and we can talk a little bit about that. So think of that as a result that says partisan antipathy can measurably degrade close family ties. What we're going to be talking about today most is high stakes decision making. And what I'm going to show you is the results of a really kind of strange natural experiment where in the middle of the 2017 hurricane season, as Hurricane Irma was about to make landfall in Florida, flashback, Hurricane Irma, most energetic hurricane ever measured in the Atlantic in human history, was about to slam into Florida. What we're going to show is that conservative media denials that hurricane was as strong as being predicted, and increasingly partisan beliefs that hurricane severity was being kind of hyped by the liberal media so as to scare people into believing in climate change, caused a huge partisan rift in willingness to evacuate an oncoming hurricane. kind of show you, I'll show you kind of like how much you should believe that. And I think that's going to be one of the main kind of proving grounds that we're going to use to try and explore this technique. And then I can show you a couple of other things later, some other kind of results that we have with respect to this. I'm going to show you that whereas now currently when we're worrying a lot about kind of socioeconomic disparities and racial disparities in vaccine hesitancy, in fact, if you look at COVID-19 vaccine testing, politics is by far a greater driver of willingness to test after receiving news that you may have been potentially exposed to COVID-19 than any other factors, than any possible other factors. Okay, so that's where we're going. All right. Let me tell you what data we're going to use, because as I said, this I think it represents a really exciting democratization of data for potential computational social science. The way to think about this is, and maybe this is also kind of an interesting warning to viewers. I can help destroy the validity of this data, at least amongst the people who watch this talk. You know, we all probably understand this. We all carry around these incredibly sophisticated sensors in our smartphones with us every day. As everybody probably knows, you know, because when you open Google Maps, it kind of immediately knows where you are. You're carrying around a GPS sensor in your smartphone. You're carrying around an accelerometer. And in fact, for most kind of modern smartphones, you're also carrying around a barometer that tells the smartphone kind of your local weather conditions / kind of your altitude. Now, you know, if you use an Android phone, you know, Google knows everything about you. They can read all of your emails, all of your texts, and kind of apply a tremendous amount of machine learning to those data. One thing that like basically any social scientist can access now is smartphone location data, which is to say, one of the things that happens in smartphones is that you carry around all of these apps you've installed, and increasingly a monetization strategy of those apps is to ask you in those pages and pages that you agree to before you can sign up and use the app, whether or not your location data can be kind of monetized and sold in an anonymized fashion into large clouds. So basically, near makes no difference. The vast majority of apps kind of use this monetization strategy, and what that means is that entirely public data, okay, you can buy for, depending upon how reliably you need the regularity of the data, somewhere between 5% and 30% of the adult American population, totally anonymized, but you can basically know where that person is, latitude and longitude, every 10 minutes, right now, and going back 3 to 5 years. Okay, so you have this like long location panel of data. To give people, yeah.
Sorry, Keith, a tiny question.
Sure.
Because I want you to get through everything, but how is it, if you can track someone's location every 10 minutes for going back 5 years, how is that anonymized? It seems like if I can follow Keith to his house, I can find out it's Keith. Yeah.
So let's say, you know, in some sense, you're entirely right. You can if you know, for example, where a person lives, and you know, for example, where a particular person works, you can pretty quickly check whether or not they're in the data set, and with large reliability figure out whether or not it's them. And then, yeah, you can have access to like where they are every 10 minutes, you know, both currently and going back in time. I mean, it meets certain kind of official standards of randomization, of anonymization. For certain subsets of the data, you know, some of the companies that will sell you these data kind of add random noise to your home location, like, you know, where they've inferred you live, they'll add random noise to location so as to kind of blur that. But Leif, I have to say, like, you know, absolutely. You know, what we mean by anonymous is becoming increasingly fraught in today's world.
Just to add to that, Keith.
And so likewise.
Go ahead, Dorothy.
Oh.
Dorothy,
yeah.
go ahead.
So I see, you know, in the hurricane analysis, so you're matching people to precincts, but in theory, except for ethical concerns, of course, you could match them to the voter file and know their party registration. Is that right? But you won't do that just for ethical reasons. But
not in these studies,
yeah.
and also not for ethical reasons. There are companies operating political consultant companies that try and do exactly this. That try and match the voter file both to smartphone location data and also actually to AAID, kind of advertiser ID identifiers, so that you can match, for example, somebody's political affiliation to the cookies that you might have that their browser will kick to any provider whose website they visit. Yeah, I mean, we could talk for a whole separate hour on what kind of modern data science is doing to ideas of privacy and anonymization. I mean, you know, it's interesting because, you know, so for example, I have many friends who, not many friends, I have some friends who, you know, own paper shredders and shred every credit card bill, every, you know, all of their mail, they shred before throwing it in the garbage, because they're like, it's perfectly legal for anybody to go, you know, once your garbage is at the curb, to go like pick through it and like do whatever they want with your garbage. So of course, you know, in some sense, you're not anonymous. Like somebody picking through your garbage knows which house you live in and probably knows whose garbage this is. We've always been protected just by the fact that it's just difficult, right? Increasingly, these kinds of activities are not difficult, which is a real issue. Yuri, did you have a?
I had a follow-up, Keith.
Abhishek.
At least when I've been trying to explore some of these data, there's kind of an inequality in density of coverage within these. So there's like the 5 to 30% number you mentioned, but in your experience, how many of those people are really, you can track them every 10 minutes versus how many devices you might see like once a month and then disappear?
Yeah, so if you want, like, I can really see you every 10 minutes. There's sometimes when that breaks down, but if you want, like, yes, I can really see you every 10 minutes and that goes back for 4 years, then like the number that you get is around 5%. If you know, for certain types of studies, you don't quite need that level of representativeness. And then these data sets, even the publicly available ones, can get into representativeness of 30% or higher. So it really varies by study. It also varies a little bit by platform. So when people buy a new smartphone, you know, Apple does, I would say, like a somewhat better job of connecting, you know, who, I just upgraded my iPhone knowing that the new iPhone is still me. Apple does, I think, a better job of that than Android. So there's a little bit of variation with respect to that. But that's basically where we're at. Okay, so just imagine that you, I mean, let's just leave it as an imaginary thing. Imagine that you have no privacy, you know, for the vast majority of Americans in this country. These data are pretty powerful if you can start inferring some characteristics of the people whose data are moving around. So you can do that in a couple different ways, totally standard way. Try and figure out what census block group they live in. Okay, and then, you know, make inferences using kind of, you know, census demographics. The other thing that we're going to do is we're going to examine people's behavior during elections and see whether or not they visit in-person polling stations. Okay, and we're also going to, using precinct level geofences, figure out where somebody lives with respect to kind of where would they have voted in a presidential election. I'll show you some other stuff about, like, you can see when people visit COVID-19 testing centers, but basically you get the idea. You can just have a pretty good sense of where people are at any given moment, and then you can just, you know, think to yourself, like, what could you infer from knowing where people go and what kinds of places they visit. Okay, that's what we're going to do. We're going to be talking a lot about politics, so let me just kind of quickly preview that, which is to say, these are voting precincts. There are 173,000 voting precincts in the United States. That's what we're going to use to infer your likely partisan affiliation. One way to, I mean, we all have experience with this. One way to think about this is, because you live on this block, you vote in that elementary school. Because somebody else lives 3 blocks away from you, they vote at a fire station that's not where you vote. What we're basically going to do is we're going to merge data about who, like, the aggregate vote shares of people who vote in these different precincts, with kind of inferences about where a particular smartphone lives. Okay, and, you know, nearest makes no difference. That information alone usually gets you about like 80-20. Like, you know how somebody voted with 80% confidence just by kind of knowing which precinct they're in, which is to say that census map I showed you before, that increasingly fewer and fewer people on this large kind of county level live anywhere near people who vote differently than them. That's in some sense like fractal, like that goes down to like any kind of spatial resolution that you want. Okay, so increasingly, these are kind of voting precincts in the United States. We're gonna lean on that. Okay, let's dive into the good stuff, which is to say, how would we identify in high stakes terms that partisan identity is shaping kind of your high stakes decision making, and then can we dig into the mechanisms around that? So I'm going to talk with you about a particular natural experiment. It's a pretty big natural experiment. I'm showing you a picture of it. This is Hurricane Irma. Again, you know, the National Weather Service basically, you know, this is off scale. This was the largest hurricane ever measured in the Atlantic in human history. That's Florida in the upper left. Okay, so this is a satellite picture of Irma, you know, shortly before it strikes the coast of Florida. Okay, beyond category, you know, I mean, many of us, I think, understand the potential destructiveness of a storm like this. Okay. What are we interested in? You know, you could say like, you know, one way to think about this is the private cost of partisan cognition, right? Like I told you before about like shortening Thanksgiving dinners. Yeah, if you're less close with immediate family, you know, that's a bad thing. When I've presented that work, some people are like, well, is it really? Can you be sure it's welfare negative if you shorten Thanksgiving dinners? I mean, you know, the turkey's usually pretty dry and terrible, and like, you know, I don't know, is this just you're just forcing people to hang out with family? And you know, and we've tried to think about other things like, oh yeah, you know, like if like, you know, you used to enjoy watching football and now it's politicized and you can't watch football anymore, that's a real cost. But a real cost is, you know, because of your partisan affiliation, like you talk yourself into not getting out of the way of this thing, right? And or not believing that it's true, despite the fact that, you know, you can see the same satellite pictures everyone else can. All right, let me tell you about this natural experiment because it's kind of cool. What we're going to do is we're going to take that smartphone data that we just talked about, okay, and we're going to watch people to learn something about their willingness to evacuate oncoming hurricanes in the 2016 and 2017 hurricane seasons, okay? 3 big hurricanes in that, at least from the US perspective, 3 big hurricanes in that season. Matthew, which strikes Florida in October 2016. Harvey, which strikes Texas in August 2017. And then Irma, that satellite image I just showed you, that strikes Florida in September 2017. What's kind of interesting from a natural experiment in partisan cognition perspective is that during the 2017 hurricane season, between when Harvey strikes Texas and Irma strikes Florida, something called hurricane trutherism really bursts to the fore. Okay, and this is actually particularly relevant too in you know, we see many people kind of, because he recently died, talking about the kind of complex legacy of Rush Limbaugh. I mean, people talk about Rush Limbaugh and Newt Gingrich as kind of, you know, 2 people who may be potentially most impactful in like the current shape of the Republican Party. Rush Limbaugh, but on September 5th, 2017, decides that for about a week, he's going to talk about Hurricane Irma as effectively a hoax. Okay, you can go on his website and you can see kind of transcripts from that whole week of broadcasting. You know, it's kind of hard to do it justice, but basically, to summarize, at the beginning of every show, he would say, I want to tell you, my listeners, I am not a meteorologist. Let me be clear to you that I am not a meteorologist. Okay, but I'm a longtime Florida resident. I'm the guy who is go-to for like installing, you know, my home's Wi-Fi router and all of this kind of stuff. And I'm gonna, and during a series of broadcasts, he claims that basically big water that's trying to sell you bottled water, the hurricane, you know, the National Weather Service and various things, and the liberal media are trying to overhype the potential risks from this Hurricane Irma, because they want to scare you into believing in climate change. Okay, he in fact at several points during these broadcasts claims he is not going to evacuate. He claims that his personal system suggests that it's not even going to strike the coast of Florida, that it's going to either dissipate or peel back off into the ocean before the supposed landing time. And he just really goes at it, okay, for all of his listeners. Remember, this is the most, by far the most listened to kind of radio show, and a very, very powerful voice in conservative media. Many other people join in, and Coulter, talks about how more people are going to die in Miami from boredom than from Hurricane Irma. It engenders a response from people who find this very upsetting. Like, he gets in a huge fight with Al Roker because Al Roker, this relatively famous weatherman, just is like, "Are you crazy? Like, this is dangerous what you're saying." Okay, all right. Let me show you. Okay, I'm going to pause my video for 1 second. We're going to do some very, very fancy
Keith, before we
Dorothy.
Before we look at these graphs, so I'm just wondering how you decide ex ante, or was it just ex post obvious that this was the most important messaging? I mean, obviously these people are spouting off constantly about everything. Limbaugh then does evacuate, right? So how do you decide ex ante that this is the thing to look at, and that we shouldn't expect to see a reversal when he leaves, or that Coulter during Harvey talking about whatever she talked about was less of a big deal and we shouldn't look for an effect there? Like, what's the ex ante decision rule there?
The ex ante decision rule into deciding this. I mean, I didn't have an alert ready that was like, I'm like deeply interested in hurricanes, and I'm like, like looking for things that are kind of moving that. I'll show you some data that suggests that, and to be clear, hurricane truth, we'll call this hurricane trutherism, which is kind of like widely known as. Hurricane trutherism existed before September 5th, 2017. But it was mainly on the kind of, edges of conservative media, like Matt Drudge had kind of flirted with it a little bit and kind of things like this. I'll show you some, for example, Google search data and other data that suggests that it really explodes exactly with this.
Got it.
That like Rush Limbaugh's really the guy who mainstreams this and brings it to kind of public consciousness. But no ex ante rule, to be perfectly clear. Yeah.
Just to add to that, do you want to think about this as independent from official? Obviously, the big thing that affects whether people evacuate is their local messaging that they get from their mayor and their counties, and that could also be partisan. And so, far as my local mayor, like, do you want us to think about this as independent of that, or something that influences that in the end influences what I do?
So that's a good question. I mean, we're not gonna trace out the kind of full causal model between like this and then reactants from like Al Roker or reactants from your kind of local mayor or any kind of that. We are going to be able to control directly for both political messaging and the timing of National Weather Service announcements and what are typically called like hurricane watches and warnings, right? Like the official way that we tell people, and evacuation orders. I'll show you what we're going to be able to do.
Okay.
Yeah, but it's an important question. All right, actually, just to ground this, let me just show you, like, forget like fancy econometrics for a second. Forget like any kind of tests that I'm gonna kind of show you. What's the first order partisan effect here? So what I'm showing you is, starting at the time when there is the very first hurricane potential watch or warning. Okay, and what these curves are is cumulative evacuation rates. Okay, as measured by smartphone location data. So if you look at the leftmost graph, by October 6th, right, approximately 10% of people living in Florida had evacuated their homes as Hurricane Matthew is approaching. That's kind of like how you would read this graph. Okay, now what the red and the blue lines here are just at the precinct level. Not even thinking about the intensity of that vote, okay? But did Trump or did Clinton in 2016 win this precinct, okay? The red line is evacuation rates from precincts that Trump won, and the blue line is evacuation rates from precincts that Clinton won, okay? October 2016, when Matthew strikes Florida, very little difference between the red and the blue lines. Harvey, that strikes Texas just a month earlier, very little difference between the red and the blue lines, okay? Irma, 2017, after hurricane trutherism emerges, you see this growing and large divergence between the red and the blue lines, okay? This is in some sense like no controls, no econometrics. We're obviously going to have to do a much better job than just this at like really, really pinning down that partisanship is what's going on here. But I just want to give you a sense of, in some sense, like the first order sniff test, what is the data telling us? Okay. And you kind of keep in mind this picture. So, yeah, I mean, keep in mind this picture. All right. Dorothy, to your earlier point, let me kind of like duck down here. One way of thinking about whether or not kind of attention, to some particular issue, like really, really spikes or really, really grows at a particular time, to think about this design, right? Like, is this really a novel intervention? You can use, obviously, Google Trends. That's what I'm showing you here. I'm basically showing you, right, those 3 lines like Matthew, Harvey, and Irma. What I'm showing you is basically normalized Google searches for much more specific kind of terms with respect to hurricane truthism, like Rush Limbaugh hurricane, Enkelter hurricane, or more general, say like distrust kind of terms like hurricane conspiracy, hurricane fake news. Basically what you see is that by almost all of these measures, like there is a real uptick. In some sense, this does feel like a natural experiment. Like there's a real uptick in the middle of the 2017 hurricane season, between when Harvey strikes Texas and when Irma strikes Florida, in kind of interest in this particular belief. So think of this as like, there's a real, can we put it in quantifiable units? You can with a little bit of survey data, but really like what I want to convey to you is there's a really discrete jump and change in the politicization of hurricanes, right? And it happens in the middle of the 2017 hurricane season. Okay, now let me just, like I was just saying, like about kind of now proven causality. This is kind of this is where like the nerds in us have a lot of fun, right? How do we prove that this is causally really about partisan cognition? So I'm going to talk about kind of 2 potential threats to that kind of inference. You could imagine, for example, like I just showed you that Democrats and Republicans don't necessarily live very close to each other. Right? How do we know that Hurricane Matthew and Hurricane Harvey didn't just happen to be more ecumenical and nonpartisan in where they strike, whereas Hurricane Irma, as it's rolling through Florida, didn't just happen to strike more Republican areas, or sorry, didn't happen to just strike more Democratic areas, right? And hence cause that kind of divergence in 2017 in Irma that we didn't see before. Okay, so we're going to have to worry about that. First order, why you might not worry about that is because these like you saw that picture of Irma, it's like several times wider than Florida is, right? So but we are going to try and have to worry about that a little, because what I'm showing you here is that precinct level voting map. For the 2016 election, both for on the left, that's Houston, the main city that got struck in Texas, and then all of Florida. It is absolutely true that Republicans and Democrats, as we said, tend to live near each other, and so you could worry about some kind of like bad spatial bad luck, I'm calling it here, or you're going to have to really control for like local hurricane intensity. Okay. The other thing that you might worry about is that either the representativeness of this type of data is changing, or there's some weird thing about who you can actually measure. I mean, like I told you, like even at best, you're getting 30% of the American adult population. If we're going to use these kinds of data more broadly to think about partisanship, how representative is it? Like, is this pretty good on a political level? I'm not going to spend too much time on this, but one way to think about testing that is to say this. We're going to infer your partisanship, right, by trying to figure out what voting precinct you live in. Okay. Now, so for example, suppose you live in a precinct that voted 80% for Trump and 20% for Clinton. I'm going to call you a 0.8 Trump voter and a 0.2 Clinton voter. Okay. Now, how do we know that that's reliable? Well, let's aggregate that up to the county level. So I see this many smartphones that live in a particular county. Okay. I'm going to take all of those smartphones, assign them partisanship using their voting precinct, okay? And then I'm going to add that up at the county level. But I actually know what the vote counts were at the county level. And so I can ask, like, this inference process, if I add it up, does it do a good job of telling me like how counties would have voted? Okay. And what you see, and if it does, then, using this inferred county vote share versus the actual county vote share, those two numbers should fall on the 45-degree line. What I'm showing you here is what that data looks like for the people we observed in Florida during Matthew, Texas during Harvey, and then a slightly different set of people we observed in Florida during Irma. And each of these dots is a county in those states, and the size of the dot is the size of that county. So you do see some points falling off the 45-degree line, but they're small, right? And hence, that gives you a sense that it may just be sampling error that drives those departures. Okay. So this is not a perfect test, but it's a test that suggests, this is a test that suggests we're doing at least a pretty good job of being representative on political terms.
I have a question for you, Ricardo.
Sure, yeah,
here.
Ricardo.
I was going to ask, like, given that you're using this for the x-axis, the Trump vote share, I was wondering whether you tried doing the exercise with historically before Trump, what was the representation of Republican votes, to see whether this is something like this is a Republican effect, or is it a Trump effect, or a combination of both? Have you tried anything along those lines?
Yeah, that's an excellent question. We haven't used, because in some, let me tell you the truth, we only have precinct geofences for the 2016 and now the 2020 presidential elections. I have thought about like looking at whether or not, swings, right? So like, people who, what do areas that looked more Republican pre-Trump, or what do areas that looked more Democrat pre-Trump, like how, what are the differences there? We haven't dug into that as deeply as I think we could. I think it's an interesting question. Is this particularly a Trump effect, or is it a more broad kind of Republican effect? We might think there are reasons it's a Trump effect. I mean, Rush Limbaugh and his listeners were particularly big fans of Trump, although they were also traditionally Republican.
You can have a question too.
Sure, go for it, Yuri.
I think it's a follow-up of Abhishek's earlier question.
Okay.
So this is like a natural experiment. What should I be thinking of the manipulation? So what, and I know you said you couldn't quite, but how would you like me to think about it as like Rush Limbaugh woke up and decided to do this, and the counterfactual is he was preoccupied with something else, or is it about like growing latent skepticism about whether in the Republican Party? Because those feel quite different. How do you think about that?
I totally get what you're asking. I think it is the $1 million question. I think of it as I do think, because it really happens between Harvey and Irma, you really do want to think about it as a Limbaugh effect. Like, what if Limbaugh had woken up that day and decided to spend a week talking about Dr. Seuss instead of talking about hurricanes, right? Like, what would the effect have been? Now, so in some sense, I think of it as an experiment of like, I showed you those graphs, those temperature graphs. Like, it's not as if partisanship just dramatically jumped on the 5th of that month, right? But in some sense, that partisanship extending to how you feel about Irma in specific, I think we do see evidence that did jump on the 5th of that month. So I do think of it as a Limbaugh effect.
Another thing that could answer that, I wonder if you tried, is to look at the next hurricane and see if that goes away or is attenuated to some extent. Did you try that?
So unfortunately, the 2018 hurricane season was actually pretty mild. Well, not unfortunately. Fortunately, the 2018 hurricane season was actually pretty mild. So I mean, we do
Dorian or something.
Yeah, we do have some kind of follow-up work. I mean, it's taken us this long just to analyze 2016 and 2017, but it is an excellent question, and it is an important question as to whether or not it goes forward. We have found that the Thanksgiving effect dissipated considerably in years even in just the next year following the 2016 election. The Thanksgiving shortening effect that we found dissipated pretty substantially. And you can see why. In survey data pre-2016, if you ask like things not to talk about at Thanksgiving, money, religion were the top two. Overwhelmingly in 2017, it was politics. Like everybody was like, don't talk. So, there, in some sense, that I think there may be kind of coping strategies. And so then to connect this to a deeper answer to Yuri's question, I mean, in some sense, like you could think of this as also kind of a novel politicization effect. And then I think there are interesting questions to what degree we develop either cognitive or social strategies that help mitigate potential costs of partisanship. So, you know.
I don't want to hold you up, but there's a question from Lucas Walrich in the Q&A asking, is it difference between cognition or information? I guess another version of the same question.
Yeah, that's a really good question. I mean, those things are intersecting here, right? Because it really is like, I mean, I think I mean, I'll plead that I am a terrible psychologist on many dimensions and am in awe of people who can actually like really, really dig into cognition on these levels. I mean, you know, I do think that that what this work is most consistent with is a partisan identity, really shaping which information you're both sensitive to in terms of allowing it to shape your beliefs and listen to. Yeah. But okay. Okay, so I'm gonna go a little bit faster now, but to Abhishek, to one of your early questions, just to give people a sense of it, and we actually, if you want to see, we have a paper that does this a little bit more carefully. I'm using the colors of the rainbow to signal like at what time and on what day kind of hurricane watches on the left and hurricane warnings were issued. Those warnings and watches tend to be issued in very clumpy forms. They always apply to counties. They apply at the county level. So we do a little bit of actually regression discontinuity, where you look at people who live just on opposite sides of the county boundaries to estimate specifically the effect of the warning, and then also the interaction of the effect of that warning with so like people who live in Trump County, in Trump voting precincts just on opposite sides of this kind of a boundary, and Democrat voting precincts just on opposite sides of this boundary. You can do a little bit of using these physical boundaries to identify a little bit more of the interaction of this with, like, you know, can we say that this is making you less sensitive to government warnings in specific? For example, you might imagine that it's hesitance to believe in your local government. You know, I'll leave this up, and it's also in the paper. You can kind of see, it's actually kind of interesting that you can actually, this is the very first time that we can see in large part, like how people evacuate and when people evacuate, where they evacuate to. So local planning agencies we've been working with, Florida is one of the few states that has its own, in some sense, like National Weather Service. And we've been working with them a little bit to kind of look at how this data can help. All right. Not particularly fancy equation, just a linear equation, but this is kind of the regression that we're going to run, okay? I'll just describe it. We're basically going to use smartphone data to talk about two different types of evacuation, a 24-hour evacuation or 48-hour evacuation. We're basically gonna think about that as like, we're gonna call people as having evacuated if they leave their home for more than 24 hours or more than 48 hours. Either measure kind of works perfectly well, and like leave their home by a significant kind of distance. We can do a little bit because we actually know, for example, the location. You know, if you go and then, you know, we see you in a hotel, you know that's further inland. You know, maybe that's more evidence. We could try and do a finer job of this. Or if you go to hurricane shelter, we're going to regress that on like Trump share. Okay, meaning the share of people who voted for Trump in your voting precinct. And then that interaction of that Trump share with after Limbaugh, so like after hurricane trutherism emerges, that's effectively basically asking, you know, did Trump versus Clinton precincts look different in prior hurricanes? Not really. Well, then, like, you know, then this is going to have to load on Trump share after Limbaugh. We're going to directly control for government warnings like hurricane alerts. We're going to directly control for demographics at the census block group level. So race, education, employment, household income, median household income, population density, stuff like this. Geographic controls, where you live, how far is that from the coast, its elevation. And then we're going to become even more aggressive with spatial fixed effects, okay? But basically, like, you know, this green column, nears makes no difference, basically tells you exactly at various levels of controls. And we're going to talk about column 4, the one with spatial fixed effects, in a second. It basically tells you exactly the picture that you saw before, that you saw in the raw data. Basically, after Limbaugh makes these comments, but not before, Republicans seem about 10 percentage points less willing to evacuate than their Democratic neighbors. Percentage points, not percent, 10 percentage points less willing to evacuate. And, if only 30%, in these hurricanes, only about 30% of people are evacuating. So this is a gigantic effect. All right, let me talk about those spatial fixed effects in a second, because I think these spatial fixed effects are interesting from their own perspective as just kind of a new thing that we can do in computational social science. There's a whole bunch of things related to space that you might worry about. Like we said, are we sure that the hurricane didn't differentially strike more democratic areas? Or do we worry that there's some, kind of thing, maybe it's that Democrats are more likely to live in cities. We know that's true, and they have different levels of hurricane, kind of how robust their houses or buildings they live in are to oncoming hurricanes. That would have cut in the other direction. But how do we know all of those things can be controlled for? What we're going to do is we're basically going to put in finer and finer and more aggressive spatial fixed effects, which have the impact of basically saying we're only going to compare people who live in the same little square. And I'm illustrating these squares. So a geohash 3, for those of you who, it's just a spatial indexing system. Those are squares that are approximately 150 kilometers on each side. Every one layer finer of spatial aggregation we're going to dive into basically takes that previous square and divides it into another, let me see, 4 by 32 smaller squares. Okay, so the geohash 4 is like, I'm only going to compare people who voted differently but live within 150 kilometers of each other. Geohash 4, 40 kilometers of each other. By the time we get to the geohash 7, you live within 150 meters of each other, but you likely voted for different candidates. What are the differences then in your evacuation behavior? Okay, and one way to think about what happens to these regressions as we dive into these finer and finer spatial fixed effects, we're both controlling for anything that is explicitly spatial, like hurricane intensity. It's very hard to believe that you experience a dramatically different hurricane than someone who lives 150 meters from you. Okay, and we're also implicitly controlling for any demographic that is just spatially correlated. Okay, right? Listen,
I have a quick question for you. Can you
Sure.
give us a sense of what's the relative size of the voting precincts? Because that's the one that you used to infer. Are they smaller or bigger than geohash 7?
In cities, they're smaller. Oh, sorry. We're also partially identifying off of the fact that the boundaries of those voting precincts aren't shaped like squares. So you can still get some residual variation. But in cities, so for example, if you live in Manhattan, you probably know your voting precinct is usually 1 or 2 blocks. Because you live exactly on this block, you vote here. So in cities, voting precincts can be quite small. In rural areas, they can be much larger, right? And so in some sense, there's no uniform answer to that. But you very well might worry that once we're down to the level of the Geo7, 150 meters, is that variation in politics still meaningful? Because you live in this precinct versus someone else lives in a different.
And if you were to overlay these squares of geohash 7 on top of the voting precinct map that you showed before, that would make it super clear.
Cool. I should do that, and I should show both rural areas and urban areas in that example. I'll do that.
Can I just, so I'm confused about the regression you just showed us is at the person level, right? There's it's just a cross section. So in that sense, it's not analogous to the first graphs you showed us, which show within Irma variation, right? You're not exploiting that within Irma variation, right? So effectively after Limbaugh is just an Irma dummy and doesn't have to do with September 5th.
In some deep sense, that's right. Yeah.
So why not use the within person panel?
You can try and do the within person panel. The problem is that here, I'll show you this again. The problem is that very few people one way, if you really look down on this, you can say listen, you can maybe do a little bit with the fact that the red and blue lines are very close to each other before Limbaugh, and then after that's when they really start to spread.
Yeah.
I find that I find that convincing, but I believe this story, right? You know, I think that the real, you can run that regression, and that regression also works. I mean, you know, I think a little bit of the issue is not very many people have evacuated by the time Rush Limbaugh really starts to lay into this.
Okay.
Okay, but it's an interesting, certainly it's an interesting experiment. Let me just, so this is going to be the last thing I say about hurricane evacuations, and then I'm going to briefly kind of preview a couple of other things that we can do on partisanship with this. But basically, what's kind of amazing, what I'm going to show you, what I'm showing you, is the coefficients that come out of that regression with these various fixed effects. Where, remember, that leftmost panel, the GO3s, you're comparing people who live 150 kilometers from each other. And by the time you get all the way to the right, GO7, you're comparing people who only live within 150 meters of each other, okay? So let me make sure I get that right. 3 orders of magnitude, it's what the metric system allows you to do, right? 3 orders of magnitude difference in level of aggressiveness of comparing you only to people who are within kind of closeness to you. Now, as Ricardo's question points out, that then, you know, you're identifying off of slightly different variation, like the stuff that identifies the GO7 regression is it's by its nature only urban, because, you know, it's only really going to be in urban areas where your voting precinct is potentially smaller than your GO7. But what's amazing is that this coefficient is remarkably stable to that increasing aggressiveness of spatial of comparison units, which is to say that this political effect, it appears to be fractal. Like it has just as much strength at large spatial levels as it does at small spatial levels. Okay, so I mean, maybe there's something to be written here about the strangely uniform fractal linear effects of partisanship. You know, that's a paper for Nature Physics or something. I don't know. It's an inside joke to people who hate nature physics. Sorry about that. Okay, so let me say a little bit. I'm just going to quickly preview some other fun things because hopefully, I mean, I'm kind of a moron. I hope people who are watching this talk do much more interesting things with these data than I can. Let me show you some kind of cool stuff. I was giving a talk at Stanford. That's why this is a picture of Stanford. You know, I was gonna just quickly preview some really cool work that Devin Pope and Kareem Hagag and I have done. You know, these are polling places near Stanford University, right? So I'm just kind of highlighting them. And, you know, one thing that we've done with these data is, you know, one kind of cool thing, machine learning actually from satellite imagery does a very good job of telling you what is the building rooftop of any particular street address that you're willing to punch in. So take some data that just says 700 Clark Way in Palo Alto is where a bunch of people will go to vote, okay? This is what like 1 hour's worth of the geolocation data looks like on a day 1 week before the election, right? Those blue dots are inside the rooftop outline of that building. You know, here's like some kids playing outside. Here's someone going for a jog down the street. To your point, Leif, this does not feel very anonymous, right? One thing that we did was then like flash forward to the day of the election, and you see first of all, a bunch of more people in the building. You can kind of infer where in the building the voting booths are, and you can also kind of see a line forming outside. Okay, so this prompts us to ask questions like, I'll dive into this, voting locations. This is the average wait time, or how long do we see people outside in those lines for voting polling places that are in the lowest decile of fraction of people who are African American or Black who have been assigned to vote at this place versus the highest fraction of the highest decile. And it shows, it allows us to measure things like an African American is 70% more likely to have to wait more than 30 minutes when voting in person, things like that, right? So you know, the power of this kind of data is pretty remarkable to scale, kind of measure things like this that we haven't been able to measure before. I'll say, and we're almost out of time, so I'm very conscious of the time. One kind of cool thing you can ask then is say like, well, can we use cell phone data like this to try and get a little bit of a resource question? You can, if you're willing to do some fancy kind of queuing theory kind of stuff. So for example, what might be, suppose you can't see through the roof of the building, what might be evidence that there are 5 voting machines in that building? Well, evidence might be when 4 people arrive at the same time, they don't slow each other down. When 5 people arrive at the same time, they don't slow each other down. But when 7 people arrive, now like each one of them takes a little bit longer to vote than when there were 5 people arriving, right? Like basically, when do people start interfering with each other's like wait times once in the building? That might give you a sense of how many voting machines there are. There's evidence that places that are systematically voting stations that are in kind of predominantly African American areas seem to have fewer resources per assigned voter. Okay.
There were multiple questions about people wanting to access such data, and so also any advice on that. I know you have a minute left, so I want to make
all right, I'll just say it's all up on my Harvard Dataverse. So like, listen, I'm trying to make, oh, the stuff that we do with the data is all up on my Harvard Dataverse site. So you can just go there. There's links to it from my UCLA website. It's all kind of, you know, we all make it kind of publicly available. And then Veriset there's several companies that work with academics and that can partner with you to get access to this deeper dive kind of individualized data set. Veriset, I think Places IQ, there's a couple that kind of have worked with a couple of different academics. I will warn you, it's 2 terabytes a day, these data sets. So it's very like, it's extremely difficult to work with and painful. But listen, I think the payoff is very strong. I'll just say this last result and then we'll end. You know what Milena de la Fuente and Yilin Zhao, 2 graduate students of mine, and I have been looking at is we're trying to use these data to look at things like potential drivers of vaccine hesitancy, and we're going to use as data towards that the preceding question of, well, if we, okay, so here's what we do. We look at like people who visit COVID testing centers, right? So like, you know, hey, there's this huge stadium. It's not hosting sporting events anymore, but you can go there to get tested for COVID. Who shows up at that? Okay, now that's kind of cool because remember, in the cell phone data, we can now rewind the clock for 2 weeks and say like, after you visited and gotten a COVID test, where have you been for the last 2 weeks? And I'm going to look for super spreader events by asking where are there times when a whole bunch of people get together and later a high fraction of them have to test for COVID. Okay, and then I'm going to ask, well, what about the other people who are at that place but don't test for COVID? What predicts who in that place does test for COVID and doesn't test for COVID? Education is a huge predictor. Politics is a huge predictor. Race, not so much of a predictor. Socioeconomic status, a very, very marginal predictor, which is I think really interesting. Okay, I want to respect people's time, but thank you guys so much. This has been really fun.
Thanks a lot, Keith. That was a lot of fun. And thanks to all of our panelists for making the time to be here and to all of our audience members for being here as well. We'll be doing this again next week, not with Keith, but with someone else. So see you then. Thanks, everybody. Have a good weekend.